What you're looking at right now is the language, not English, not French, not Mandarin. It's the one language spoken by every engineer, architect, and craftsman on Earth. And by the end of this lesson, you will start to read it. Welcome to Introduction to Technical Drawing. Let's start by training your eye. Look at these two drawings. Same subject, a simple bracket, drawn two completely different ways. On the left is a technical drawing. Notice the multiple views, front, side, and top, all linked together so a manufacturer can reconstruct the part in 3 dimensions just from these flat views. Every edge is measured. The dimension lines tell us this part is 90 millimeters across. A title block in the corner specifies the material, the scale, and the tolerance, plus or minus 0.05 of a millimeter. Nothing here is left to feeling. Nothing is approximate. On the right is the same bracket, sketched freehand. The artist captured its form and mood with loose, expressive strokes. Notice there's no second view, no dimensions, no tolerance. The proportions can bend for visual effect. This drawing aims to be felt, not measured. That's the core distinction you need to lock in today. A technical drawing exists to be measured and manufactured. An artistic drawing exists to be felt and interpreted. Same pencil, completely different job. So let's put a precise definition around what we just saw. Technical drawing, also called drafting, is the discipline of producing drawings that visually communicate exactly how something functions or is to be constructed. It's the working language shared by engineers, technologists, technicians, and craftsmen, the common ground that lets very different specialists build the exact same object the exact same way, no matter where in the world they are. And here's a term worth remembering. When this same discipline is practiced by hand, without rulers or instruments, we simply call it a sketch. 3 qualities define every true technical drawing. First, it is precise and accurate. Every dimension is measured. Every tolerance is exact. Second, it is fully detailed. Materials, finishes, and assembly notes travel with the drawing, not in someone's head. And third, it is outline governed, meaning lives in line type and symbol, not in shading or mood. Now, where is this language actually spoken? The honest answer is, almost everywhere industry exists, and each field even has its own dialect. In mechanical engineering, parts are drawn with full dimensions, bore sizes, and a title block specifying material and tolerance, like the flange you see here. In architecture and civil engineering, the dialect is the floor plan paired with an elevation. One view shows the room layout from above, the other shows the height and roof line. Electrical engineering speaks almost entirely in schematic symbols, resistors, capacitors, and ground marks, with reference values instead of realistic pictures. Graphic design borrows drafting's precision for layout grids and packaging D-lines, the fold lines that tell a printer exactly where to cut and crease. Surveying and mapping use contour lines and compass bearings to translate real terrain into a scaled site plan. And on a construction site, crews build from section details, like this footing detail, showing rebar spacing and depth that a photograph could never specify. 6 very different industries, 6 different drawing styles, 1 shared language underneath all of them. Here's the idea to carry with you. If it gets built, it first gets drawn. You now know what separates a technical drawing from every other kind of drawing, and you've seen 6 industries built on top of this one skill. In our next lesson, we pick up the actual instruments, pencils, set squares, scales, and modern CAD tools, and start drawing. I'll see you there.